Hello everyone, and welcome back to the Fluctus Channel. Aircraft carriers have the most active flight and hangar decks of any other ship, in order to keep 90 aircraft organized, coordinated, and ready for action. It takes a massive effort from everyone on the aircraft decks, but especially from the air boss. A U.S. aircraft carrier's flight deck is like a well-tuned symphony. Every day, approximately 5,000 crew members work together to launch or recover up to 220 aircraft, with a maneuver occurring every 37 seconds. Their color-coded outfits allow for exact assignment identification, ranging from ordnance handling, red, to aircraft directing, yellow, ensuring safety and efficiency in the high-octane atmosphere of seaborne aviation operations. U.S. Navy aircraft carriers are commanded by a captain, but the aircraft are the responsibility of the flight officer, also known as the air boss. At land-based air bases, the air boss would oversee the air traffic control, or ATC, tower. Aboard carriers, his job is not much different. He just has less space to work with, so it must be much better coordinated. The air boss's tower is called the Primary Flight Control, or Pri-Fly, and is on the highest deck of the island.
So I have the air department, approximately 600 personnel on board that range in responsibility from aviation fuels to aircraft handling, to aircraft directing, to the arresting gear, and catapults.
From the Pri-Fly, the air boss and the sailors with him must keep track of all aircraft, how much fuel they have, what ordnance they're carrying, where they are in relation to the aircraft, and many other variables. Pri-Fly holds the Ouija board, which is effectively a scaled physical replica of the flight deck. On this board, miniature representations of each aircraft on board are moved to reflect their real-time positions on the deck. This contributes to the maintenance of situational awareness, control, and administration of all aircraft operations. The Ouija board operators, nicknamed handlers by sailors, work closely with the Integrated Catapult Control System, or ICCS, or bubble. The handlers and the bubble's symbiotic relationship allows seamless coordination, quick decision-making, and efficient execution of aircraft operations, whether launching, landing, or on-deck movements. But landing and launching aircraft is not just about controlling aircraft. The ship's course and headwind also play a role. An aircraft carrier's engine room, or propulsion plant, is constantly active, enabling efficient aircraft launches and landings. Nuclear-powered engines use conventional steam turbines to power huge propellers, generating the power required for the carrier to maintain the required speed and heading. The ship turns into the wind for aircraft takeoffs, increasing the relative wind speed over the deck. This greater wind over the wings, combined with the carrier speed, increases lift, lowering the length of the runway required for aircraft launches. The ability of the engine room to control the carrier's speed is critical in this. Similarly, the carrier's consistent speed allows aircraft to land safely at a constant speed relative to the ship. The engine room collaborates closely with the flight deck and air officers to maintain stringent speed parameters for safe and successful operations. Aircraft carriers use a specialized platform known as a bubble, catapult control station, or integrated catapult control system, or ICCS. This critical nerve center supervises the steam-powered or electromagnetically powered catapults that push aircraft off the carrier's deck, converting a paltry 300-foot deck into a viable runway. The Bubble's crew, often deck officers with great expertise and training, manages and verifies each aircraft's weight and required speed for launch to guarantee a safe and successful catapult launch. Within the Bubble, integrated touch control screens and digital displays provide a detailed picture of ongoing procedures. As a result, the Bubble is critical to the carrier's seamless and thorough orchestration of complex flight operations. A well-choreographed ballet of technology and human expertise emerges during an aircraft launch controlled from the catapult control station, or Bubble. The launch cycle begins with the aircraft being hauled into position on the catapult by the flight deck crew, wearing green jerseys. The weight and type of the aircraft are then communicated to the Bubble, allowing the crew inside to determine the exact steam pressure for steam catapults or power setting for electromagnetic catapults required for a successful launch. The catapult officer inside the Bubble, known as shooter, signals the pilot to increase the aircraft's throttle to full power after checking the aircraft's exact placement and deck clearance. Following a final safety check, the shooter depresses the fire button while watching both the aircraft and specialized control screens within the Bubble. This move activates the catapult, pushing the aircraft off the deck and into the sky in a matter of seconds. The Bubble's launch evolution concludes with the successful launch of the aircraft, signaling the beginning of a new cycle.
Confirm, get 3.
The Ouija board stays at the forefront of all interactions, with handlers constantly updating it to reflect current deck situations. Communications are often carried out using secure radio channels and hand signals, resulting in a complex information loop that ensures seamless, safe, and efficient flight deck operations. An aircraft handling officer, or AHO, also known as a deck handler, choreographs the complicated ballet of aircraft movements on the crowded flight and hangar decks of a ship. A typical scenario begins with the requirement to prepare an aircraft on the flight deck for a mission. The AHO plans and works based on direction from the Pri-Fly, who coordinates what they know on the Ouija board. Once the aircraft must land, another crew member takes responsibility. Landing signal officers, or LSOs, are critical players in carrier flight operations. They are responsible for assuring every aircraft's safe recovery within the final seconds before arrival on the deck of an aircraft carrier. Armed with extensive knowledge of each aircraft's performance capabilities, they direct the pilot using a unique light system. The Fresnel lens optical landing system, and verbal instructions over the radio. LSOs must not only comprehend the equipment, but also read the pilot, identifying stress or tiredness symptoms that could risk a safe landing. Furthermore, LSOs rate each approach and landing for training and documentation purposes. They examine every detail, including the pilot's altitude, speed, rate of descent, and alignment, as well as the landing itself. While there are 4 decks to take off from, there's only 1 deck to land on. Therefore, they can cause a bottleneck if they don't act with precision and speed. U.S. Navy aircraft carriers are, simply put, air bases at sea, but with almost no space. Due to the lack of space for landing and takeoff, the flight decks, hangar decks, and other parts of the ship, like the engine room, must work together harmoniously. Before the 20th century, the refueling process of a ship relied on coaling stations set in key locations for the fleets to get the required fuel during their travels. However, this demanded multiple defended locations during times of warfare, which resulted in an infrastructure that was constantly in danger in case of any disruption. The development of a new system in which a ship could be refueled at sea by another ship, called underway replenishment, started in the early 20th century, achieving operational use during World War I and was used extensively during World War II. After this period, the alongside connected replenishment method was created to transfer liquid fuel as well as ammunition and goods between ships. Nowadays, newer technologies like the standard tensioned replenishment alongside method or the involvement of aircraft, such as helicopters, are used to transfer cargo in a method called vertical replenishment. The refueling process requires using a span wire fueling rig that extends the hose from the delivering ship to the receiving ship at a safe distance. In the case of bigger ships like aircraft carriers, multiple rigs are used to increase the load transfer rate. It is important for the crew to maintain control over the safe distance between the ships, as 2 ships getting closer might create a suction event and an eventual crash. The arrival of the 21st century led to the development of a new design with a heavier capacity. This meant that the system could transfer 25 loads of 12,000 pounds per hour. Aircraft carriers represent the pinnacle of naval innovation and coordination. Every operation, whether launching a fighter jet or conducting underway replenishment, relies on precision, communication, and an unbreakable chain of teamwork both above and below deck. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.